Okay, so we're back with our second screencast for your notes so that you can actually get some sort of value out of these. Okay, so we were talking about last time the hardness, so its property of minerals. Once again, we measure it with the Mohs hardness scale from a scale of 1 to 10, diamonds being a 10, talc, T-A-L-C, being a 1. You can scratch talc with your fingernail. We're going to be doing some activities where you try and measure the relative hardness of certain sample minerals. You get to use things like your fingernails, and then you get to use things like actual nails, copper pennies, things like that to see in a range of what type of minerals are softer or harder. Typically that ends up being a surprise because there's certain minerals that you encounter on a daily basis that to you think, well, that's relatively hard, but it ends up being able to be chipped with a penny pretty easily. Here's a picture of the Mohs hardness scale. Let's just check it out for a minute. Okay, at the very bottom of the Mohs hardness scale is talc. Once again, you can scratch anything underneath a 2.5 with your fingernail. So that's talc and gypsum. Calcite ranges just right above the fingernail, so you cannot scratch it with your fingernail, but you can scratch it with a penny. Things to keep in mind, things in daily life that are made of calcite and gypsum would be chalk. Sheetrock is typically made of those two things. I'm trying to think if there's anything else you encounter on a daily basis. I think that's it for calcite and gypsum. Most seashells and stuff, well, not seashells, but let's say fossils in general of sea creatures end up being made a lot of calcite and gypsum. So that's why they don't necessarily preserve super well. We've talked about that during the fossilization techniques because it's really easy to dissolve chalk in water. So that's our problem there. Okay, we've got fluorite, which is a really cool looking mineral. Can be typically found in a teal color, like a bright blue or a purple. Okay, so it is above the copper penny, but you can scratch it with a nail, like a construction nail that you would use. Okay, let's go above. There's apatite. That's where we get to the knife, orthoclase. Quartz. Okay, so quartz is up there as one of the top 3 hardest minerals, which is kind of surprising, but quartz is a giant money maker for companies in the world, and they quarry it a lot, and so there are tons of quarries around here that use dynamite and blow up places to get out the quartz. So quartz is an incredibly financially gaining type mineral. Okay, so it's above everything, and so quartz is one of those things that it'll scratch the streak plate, but the streak plate will not scratch quartz. And so once you get above 7, it gets more difficult to figure out the hardness because there's not as many things that that will scratch those minerals. So of course we have quartz, and then topaz. A lot of you are probably familiar with that. Corundum. And then of course at the very top, standing alone all by itself, is the diamond. The diamond is always going to be the hardest mineral you're ever going to find. It's notorious for being the hardest mineral you're ever going to find. Nothing scratches a diamond. Nails will not scratch a diamond. Knives, not pennies, not your fingernail, none of that will scratch a diamond. So a lot of people ask me, how do you cut diamonds? Well, typically they have to cut diamonds with a laser. And so that's one of the only things that will cut a diamond. It's actually pretty cool. Diamonds are really cool. Now we do man-made diamonds. It's a long process. But anyway, essentially, so we have our natural diamonds, which are becoming rarer and rarer. But remember, those things all formed during the Precambrian era. And so what we have on the planet right now is a fixed number. And I mean, yes, ideally speaking, in millions of years from now, there could be more diamonds due to heat and pressure. But that's extremely unlikely. It's not something you would consider renewable at all. You would need an incredible amount of carbon to be placed in that situation. Okay, here we go, cleavage. Okay, so there are 2 different types of ways that minerals break apart. and it's called cleavage and fracture. Okay, so just keep in mind it's like you're either going to have cleavage or you're going to have fracture. Okay, and the term to cleave or cleavage is used a lot in science and biology. They call it a cleavage furrow when your cells are splitting apart. And so to cleave just means to break apart. So usually it gets some giggles, but bear with me. Okay, so cleavage is just that the mineral, when it does break apart, has clean, even, flat surfaces. There's not tons of fragments just bouncing off all in different shapes. It's very clean. It breaks on thin lines, sometimes even into slivers all about the same thickness. It's really cool. If it has cleavage, it's very convenient for us. Here's a picture of cleavage. It's mica. This is one of the really cool ones where it breaks apart in really thin sheets. It almost resembles fish scales. This is a perfect example of cleavage, and it only cleaves in one direction. You can see it just cleaves flat and straight across. This doesn't break off, so it cleaves really cleanly, and that's amazing for us. Okay, so here's fracture. This is when it doesn't show cleavage. It's not clean and easy. It's uneven. It's all over the place. It's not smooth. That's fracture. And so when you're looking at, we'll get you an ESRT, which is an Earth Science Reference Table. You'll get to see the common minerals that have fracture and which ones have cleavage. It's usually about half and half. So you just kind of have to go with it. Here's conchoidal fracture. This just means that it is in the shape of like a clam. That's conchoidal. It's not even. You can see this is not a clean sheet. This is not an even thickness. It's kind of all over the place. Okay, so density is a property of minerals, and it's mass over volume. So M, divided line, V. It looks like a heart if you do it right. It's just the density. Density is different from weight, okay? And density is different from mass. So it's more of a scientific thing that you use in chemistry a lot, and physics for that matter. Distinctive properties. Okay, so this is like an extra category called distinctive properties of minerals. This is a category in which things that are really neat or outstanding about that mineral get their own category. So examples would be pumice can float on water, magnetite is magnetic. Different things like that would be halite is it can dissolve ice and snow. So that's what we put on the roads when they say they're going to salt the roads. That's what they're putting on. They're putting on halite. So just categories like that go in like an extra. These are really cool facts about these minerals type things. Okay, so it looks like that's where we're going to end this podcast for today. If y'all have any questions, please email me. I'll still be checking my email all day while I'm at this wonderful meeting. And I'm going to put on the notes for the rock cycle now, okay? So draw a little line, get out a new piece of paper, all of that jazz, and we'll start the rock cycle. See y'all when I get back.